class. We're almost done with the calculus class 1. So just be there with me. We are going to study 6.2 and then next one will be 7.1 of the substitution. Then we'll be done. So 2 more to go. So today we are going to study about antiderivative, which means we learn about derivative, we're just doing backwards. So we had a function. If you have a big function f of x, if you take a derivative, then we write it this way. I didn't use equal sign, careful. Then this we call as our normal function f of x. So look at the relationship here to here and here to here. So this will be derivative and then this will be antiderivative. But antiderivative will become integral. Yeah. So let's careful. Now what is the fundamental theorem of calculus? Do you guys remember? So let's recall one more time. If you want to pause it, then just pause and try to write as much as you can and then compare with me. So I'm going to write my fundamental theorem of calculus. Fundamental theorem of calculus. If you still do not understand, just go and click YouTube. There are a lot of videos about this one too. I'm sure they explain better than me, so try that. So fundamental theorem of calculus is if your function, or you have a continuous in f of x is continuous on a to b, then we say f of x is actually derivative of the original function. Then what's the relationship between big F to little f? If I want to find the area under f over x function, so if we have any function continuous a to b, I want to find the area underneath, and this function is f over x. Then this is going to be same as take antiderivative and big FB minus big FA. That's what that means from A to B. So just look at the relationship now. There's a relationship between the little f to big F, and these are here to here derivative, here to here antiderivative. So you're just basically learning about opposite operation, like addition, subtraction, multiplication, division, right? If you have a square, you have a square root. So if you have a now dy dx, what's the opposite operation? That's going to be integral. Yeah. So that's what we are learning. So now let's look at appetizer. So last time we take the derivative from this direction, but now I'm going to go backwards. So I want to actually start it from, first one. I will do first 4, and then you guys can do next 4, and then we break it down. There are a lot of them right below. So 8. I want to take the integral respect to x. And what would be? For me, I learned that derivative is easier. So I guess, 8 came from 8x, and then take a derivative, and then see if you get the same answer. Yeah, I did. If I take a derivative, I get 8. So my antiderivative will be 8x. Okay. And then from here, I have to be careful. There will be plus c as a constant we are going to put on. I'm going to explain to you this one a little bit after. Hopefully I don't forget. Let me draw somewhere. Okay, so next one, I have an x, but this is my after take derivative. Then what will be my original function? So this one I'm going to explain to you slowly. In order to get x, I know that it has come from x squared. Because of power rule, one power is gets smaller. So I'm going to take a derivative. If I take a derivative here to here, what do you get? Do you see you get 2x? But I only have an x here. So I need to get rid of this 2. What is the opposite operation of multiplying 2? Which is dividing by 2. So now look at, I'm going to get rid of this one here, divide by 2. So now take a derivative one more time. And then 1 over 2 as a factor, I have a 2x. If you take a derivative, do you get x? Yes, that's how you get. So yes, you can do antiderivative backwards, you can, but for me, I like to just take derivative for a while. So just look at how I approach. So now I have x squared. Just x squared, where does it come from? It has come from x cubed. At least you can guess that, right? Then if I take a derivative of x cubed, what do you get? I get 3x squared. But this one, I do not have a 3. So how am I going to get rid of that 3? I can start with multiplying in front here. So now, take a derivative. Then I have 1/3, take a derivative 3 times x squared. As you see that cancel out, right? So you're gonna have x squared. So those who see patterns, that's awesome. That's awesome. And if you don't see it, then just keep deducing from my thinking. I do that deducing. I don't memorize. I don't like to memorize because I always forget or wrong. So now I will guess x to the 4. Take a derivative will give me 4x cubed, but I don't have 4 here, so I need to divide by 4, which is multiply 1/4, and double check what is the derivative of this one. Do you get this? You get this guy, which is going to be 1/4 and 4x cubed, and cancel out, so you get this one. Then you can say that this is antiderivative. Okay. So I'm going to now put C here, and let me explain two different ways. So if you have 2x plus 5, 2x minus 4, 2x minus pi, if you think about all of these cases, what is the slope? What is the dy dx? Do you see all as 2? 2, 2, 2. Yeah. Also, let's look at graph here. These are all same graph, but this is going to be x squared. This is x squared plus 2, x squared plus 4. And as you see, my derivative is all the same. It doesn't matter where it is, up and down. It's your y-intercept doesn't matter. Y-intercept doesn't matter because when you take derivative, it goes away. So we can always put constancy, and then later on next semester when they give you one specific number, you can plug in and then get that C value. So now I want you to pause and then try in-class activities for quickly. So let's look at my answer. When you see integral of 0, what would that be? Any constant number. Think about 5, 6, pi, e. Yeah, e is okay. Yeah, e to the 0. E should be fine because it's a number. And -4, it doesn't matter. Any number is going to be, if you take derivative, it becomes a 0. So antiderivative will be any constant number, real number. It can be 1.54. Next one, compare this one. If you got this one, that's good. But did you put plus C, plus C, plus C? Okay, make sure. So that's the answer. So let's study about now next one. Next one will be a little bit more challenge than what you have last 4. So I want you to do 1, 2, 3, 4, 5, 6, 7, and then you're gonna do next 7 of them. So this time is a negative power. And how should I do this one? So in order to get -4, as I said, guess, and then what will be your derivative? So it will be x to the -3 or -4, -5. So you can see that it's going to be one number plus, so it's going to be -3. So now take a derivative. If I take a derivative, that gets me -3 times x to the -4, but I want to get rid of -3, so I have to multiply it -1/3. So you probably saw this pattern, right? You saw the pattern. I definitely saw the pattern too. Then how about this one? What would you do? What would you do? So 1/x. So what is the derivative come from? So this is actually -1, 2. But now you have to remember the formula. Do you guys remember natural log of x? Yes, that's what it is. And then don't forget plus c, don't forget plus c. So if you take a derivative, you get 1/x. So that's a tricky one, just remember carefully. Next one, x to the 1/2. Guess where it comes from? That comes from x to the 3/2. So I want to get rid of 3/2 when you take a derivative, so I have to multiply 2/3. So whenever you do more, you will get it faster, okay? So take a derivative and see if you get it, then this becomes antiderivative. If you say antiderivative right away, that's really good. My brain doesn't work that way, that's why. And e to the x, we know that e to the x, so you just take a derivative. Now, 3 to the x, anybody remember? I know 3 to the x, let's take a derivative, what do you get? That will be natural log of 3 times 3 to the x, right? But is the natural log 3 number? Yes. So we can just divide it 1/natural log of 3. And then you take a derivative, then this will cancel out. So we can say this is antiderivative. Don't forget C there. So now, sine, I'm not taking derivative. What makes a sine x when I take derivative? That will be negative cosine x, right? Because the cosine derivative is going to be negative sine x, so another negative will make it. So this will be antiderivative. Almost there. Secant square x. Where do you remember secant square x? What derivative makes a secant square x? That was tangent x, right? Tangent x taking derivative was secant square x. So the antiderivative will be tangent x, right? So for me, I always easier this direction. Now there are 7 of them. Pause it and try. And there's some hint here, so keep trying. Okay, let's compare. So this integral we call as a indefinite integral. Why? Because this is a function. Before, when we have a to b, this becomes a number because of area. But also, yes, this is the area under the curve. But since we didn't put a to b, we call it indefinite integral. Okay, so basically it shows this whole curve under. Yeah. So I want you to compare the answer with me, and then don't forget, did you plug in? Did you put plus c? And then we didn't learn this one yet, and then this one we're gonna learn next semester in Cal 2. This is the tangent integral. It doesn't look pretty, right? But pretty cool that you can combine in a natural log and cosine. That's a pretty cool function. So that's the answer in come see me and main dish. Okay, class, so let's look at our main dish. I'm going to do main dish 1, 2, 3, which is 4 questions, and you guys are gonna do in-class activity 4 of them and try compare with me. So integral also has the same rule. You can separate the integral this way. Of course, you can do it at the same time too. So I learned that above there, this integral comes from 1/3 x cubed. If you do a lot, just it will come to you automatically. Plus this integral will be 5x comes from, oh, this is a little tricky one, x squared, and then I'm gonna check this one. So I know that it comes from x squared, then I'd like to take a derivative that becomes a 2x, right? I wanna have a 5x, then you have to multiply 5 and divide by 2. So why? You wanna cancel out 2, but you wanna have a 5. So I'm gonna have a 5 over 2 here. You can just break it down slowly. If you do 2, 3 times, you will see the pattern definitely. That's what happened to me too. Or you see it how I do. So that I get 5 over 2 plus c, don't forget. So this is now integral function, antiderivative function, which means this function, if when you draw, you will go, the area under the curve will be this one. So if you factor this one 0 and -5, I see that my function will look like this way. Then if you want to find the area, whatever you're saying it, that will give those area depending on. Okay, so next one, now with the trig function, careful. Sine, what is the antiderivative? So guess from here, I'm gonna guess from cosine x. If I take a derivative, I get negative sine x, therefore I'm gonna multiply with negative again. Same thing, here to here, I wanna take a derivative to get 4 cosine x. So I'm gonna try sine x is cosine x after derivative, so I have a 4, and then see if this will be your derivative, and then plus c. Of course, as I said, you don't have to do my way, but this is I like to do this way so that I don't make mistake. So now, is this a definite integral or indefinite integral, class? This is an indefinite integral, which means we get the function, right? But this time I'm going to find 1 to 2. This is an indefinite or definite? That's a definite integral, right? So definite integral will give me a number. So this one, let's take a derivative 4x cubed. So where does that come from? X to the 4th. Okay, I'm going to take a derivative. What do I get? 4x cubed. Oh, so I guess my answer is x to the 4th, because when I take the derivative, I get 4x cubed, right? So 4x to the 4th from 1 to 2. Now using fundamental theorem of calculus, I'm going to plug in 2 to the 4 minus 1 to the 4, 16 minus 1, I get 15. So area under the curve of the function looks like that, and from 1 to 2, the area is 15. Okay, so this time let's do with number that is the 5. So instead of 4, then same idea, right? So your guess will be x to the 4th power. Now take a derivative. If I take a derivative, I get 4x to the 3rd power. So this one is the same, but I want to get 5 instead of 4. So I have to get rid of 4 by dividing, multiplying 5 to have a new one. Hope that makes sense. And then take a derivative one more time. Then do you get 5x cubed? Yes. Then this is your antiderivative. So since it's a definite integral, we can compute the number from 1 to 2. Okay, so plug in one more time. That's your 5 over 4, 5 over 4, and 2 to the 4th power. Minus 5 over 4 times 1, right? So class, look at, oh, that's 1. 5 over 4, can I factor out? And do I know this? Yeah, that one, where did it come from? That was a 15, right? So 5 over 4 times, where do you had it from there? So I'm gonna just borrow. Of course, you can multiply. I don't think it's that bad. You can use calculator too. So that, oh, it doesn't cancel out, right? Sorry, shouldn't cancel out. So 5 times 15 is 75 times over 4 is the answer. Multiply. So 75 over 4. So I want to see how much as area. So 75 divided by 4. I got 18.75. So when you have a 5 instead of a 4, do you see that? About 3.75, a little bit bigger of your area. So now there are 1, 2, 3, 4. I want you to try those 4 questions and then compare with me. Compare the answer with me, just straightforward. Always double check with taking derivative and don't forget the constancy. And let's look at next answer. Okay, let's check the answer in class activity 5. So I got 7 and here's my antiderivative. And then here's I got 11 and 2/3 antiderivative. Try to do it without calculator too, okay? So let's do some dessert. So dessert, as you have observed, I'm gonna put some fun game part. So this is gonna be fun, little challenge, but it cannot be if you keep practice with me and look. So we are going to look at first dessert number 1. I like to compute. Do you recognize what is this antiderivative will be? Yeah, if you say tangent theta, that will be good. Do you remember tangent taking derivative becomes the secant square, which is 1 over cosine square. So they basically say this number from 0 to pi over 4. So since it's a definite integral, we can compute tangent pi over 4 minus the tangent 0, which is 1 minus 0 is 1. Okay, later on, I want to see the graph of 1 over cosine squared theta. And I want you to feel that. Don't you think it's actually really beautiful number? Sorry, I didn't put it into graph. I wish I could show you, but you can go and then see. And actually, my graph is going to be, oh, I think I need a secant square. And then my graph under the curve, the area is exactly 1. That's pretty beautiful number to me, right? And next one is going to be, I have e to the, if I have e to the x, then I know it's going to be e to the x. But this time I have e to the x over 2. Anybody see as a chain rule? So let's take a derivative. Then that will be e to the x over 2. And then that's outside, just take a derivative e to the whatever is e to the whatever. And then now I'm taking derivative of inside. What would that be? X over 2, which is 1 over 2x. So I get 1 over 2. So if I take a derivative of the same function, I get 1 over 2 of the same function. Now do you see what I need to multiply? Yes, I'm going to multiply 2. Then that is going to be my antiderivative. And then double check. If I multiply it by 2, do you get this one? Then yes, that will be answer. So let me write it nicely. It will be 2e to the x over 2 plus c. Don't forget that c because it's an indefinite integral. Then let's look at one more. Okay, now dessert number 3 is actually really delicious. So I want you to try with me. A little bit tricky, right? So integral 3x squared cosine x squared. It comes from a lot of practice too. So from here, I'm gonna guess what will be antiderivative. Can you guess as a sine x cubed? Because I know the sine becomes cosine. And then in the chain rule, we don't change anything inside. So that's my guess. Then let's take a derivative. Which I will get cosine x cubed and chain rule 3x squared. Do you see that? Everything? So actually, my antiderivative of this whole thing is sine x cubed. And as taking derivative, I prove that this is your derivative, antiderivative. Then that's your answer. Don't forget plus c. Little bit weird, right? Little bit difficult too. So I want to keep looking because we are going to do advanced one of this one on chapter 7.1. So just practice it here with me a little bit. So now you have 5, 6, and 7. I want you to try these 3 questions and then compare the answer with me. Okay, I hope that you enjoy integral. I personally like integral a lot. It's fun. I like a derivative too. So those are the answers and then compare with me. Always check with derivative. Derivative is easier, right? Okay, class, let's look at these are 3 and 4. These are pretty delicious. So I want you to guess what would be my antiderivative. And as you see the chain rule, because I see that those are two functions multiplied. So I feel that there are two chains there. So my guess is e to the cosine x. So let's take a derivative. E to the cosine x, I get e to this cosine x times cosine x taking derivative makes negative sine x, right? So I want to have a positive, that means I have to have a negative in front. So I'm going to multiply here. Don't forget C, so this is my answer. This is my answer. And keep checking with derivative. So now, everybody pay attention to my next dessert. This dessert is going to be pretty fun. So I want to find the integral. Now look at this as you see this times this. So do you see that? Also it's gonna be chain rule. The chain rule, when you have a two circle, you multiply outside inside. So I guess this one will be chain rule. So look carefully. First chain should be square root. So what will be my antiderivative? That comes from power to 3 over 2. Because that taking derivative gets me 1 over 2. Inside we don't touch it yet until you taking chain rule. So now I'm going to guess from here to here. Let's take a derivative which will be 3 over 2 and then x to the 4th plus 6 and 1 over 2 give me square root. Okay, don't forget. So I have an outside function done. Now I have to do inside function that gives me 4 times x cubed. Okay, everybody so far so good? So look carefully. When I'm taking derivative here, I see only this one and this. Then I do not see that 6 over 6 here. If you multiply, do you see that that's going to be 6? So I don't see 6 here. So what should I do? This is a 6. In order to get rid of that 6, I have to multiply 1 over 6. That means this I will have a 1 over 6. Okay. If you want to take a derivative one more time, then you will see that one. How was it? It was a pretty headache, right? So that's the way you can do. If you keep working on a lot, then you will see that. Now I'm going to show you substitution method. Substitution method, which is there are some variables that are really hard. So I'm going to substitute. This time I like to substitute m as x to the 4th plus 6. Okay. Then my equation will be easier to write. So now I'm going to rewrite this equation using substitution. Then I will have integral x cubed square root of m dx. But that's not done yet. Because now I have m. What is the other one? I have x terms here. So look carefully. Take a derivative of m respect to x. Then that's going to be dm dx. Do you see that? Implicit. I took a derivative of m, which is 1. So I have to indicate dm dx. So I force taking derivative in terms of x. So next one, since I have x, I don't need to write any of this. So 4x cubed. Now look carefully. I need to find here this function. I already have a square root of m, but I have to deal with x cubed dx. So I'm going to manipulate my equation here. Multiply dx each other, then I get dm is equal to 4x cubed dx. Do you see it? I'm almost there. Then what is it? X cubed dx. X cubed dx is 1 over 4, because you have to divide by 4. 1 over 4 dm. So, Young-han, can I substitute? Yes, so you are going to change everything in terms of m now. X cubed dx is 1/4 dm. Ooh, I'll just write this one here so that you don't get confused. 1/4. Now, if you look at this, does this look familiar? That's the integral of m to the 1 over 2. We learned that previous, right? So let's take an antiderivative of this. Why? Because now we have everything in terms of m. So if I take the antiderivative of m to the 1 over 2, get me, and then 1 over 4 we're going to deal with it a little bit later. You can factor it out front. That will be m to the 3 over 2, and then guess that's going to be cancelled out as a 2 over 3, right? Now what did you do? Well, this is the taking derivative get me m to the 1 over 2. Is that correct? So that's my antiderivative. Keep practice. Then you will see easily. Where did you get 1 over 4? Well, I had this 1 over 4, so I just copy it down. And then what about this? That's this guy. So organize. If I organize, 2, 4 cancel out. So I have a 1 over 6 and to the 3 over 2. Younghan, are you done? Almost. So I have 1 over 6. What was the n come from? Yeah, n was x to the 4th plus 6. X to the 4th plus 6 to the 3 over 2. Yeah. And don't forget plus c. And as you see, same answer. And plus c. Don't forget. So this is, if you practice a lot, you may see it. Like for me, just comes with a lot of practice. And then if not, you can substitute and make it simple. I know it looks harder, but once you get familiar, it gets easier. So please practice so that we can continue at 7.1 later. And practice with in-class activities and staring at it. Good luck. Okay, so sorry for fix those numbers. And when you look at this one, I hope you got this one okay. And just use, if you have a 2D multiply, that means you are going to have 2 circles as a chain rule. And don't forget plus C. So I'm going to explain in-class activities one more time because we're going to continue this on 7.1 with really fun, challenging questions. And that's going to be it. So for me, I just do backwards and then I guess first this one and then take a derivative and then it turned out to be 9 over 2. So I multiply 2 over 9 to cancel out no consonant in front of the x squared. But now I'm going to use substitution. So if I use a substitution, you want to substitute this number as a simple way. So you can use it m is equal to x cubed plus 4. Then I can rewrite my equation as a square root of m. So I'm dealt with this one. But now we have to get rid of x squared dx. So x squared dx, we have to find how we can replace everything in terms of m. So take a derivative, that makes dm dx. In place of derivative, that makes a 3x squared. Now, if I multiply both sides by dx, I get dm is equal to 3x squared dx. Now I see the pattern. Ooh, that's right here, x squared dx. So I can rewrite everything in terms of a m. So I can rewrite this one to this one. So let's substitute back and ready. So integral and square root of m, and then I have a x squared dx left. X squared dx is 1/3 dm. If you don't like that 1/3, you can always pull it in front. So I can put it 1/3 integral of square root of m dm. Then we can take an antiderivative of this one. So if you take antiderivative, it will be n to the 3 over 2 and 2/3 because you have to cancel out your factor. And almost there. That will make 2 over 9 and then n is x to the 3rd plus 4 to the 3 over 2 plus c after substitute back. So that's what I got as my answer, which is the same as up here. So I want you to see, I'm okay with either way you're using it. Just some people see this way directly, some people will see this way better. So I do not say which one I prefer, that's just a different brain. So just once you practice this one, you may see this one more automatically. So just keep practice with me of the homework. So this is it for chapter 6.2, okay?